Yes. All right. So if you had me last year, you already know a little bit about degrees versus radians, right? You know a little bit. I think we're all familiar with degrees. Degrees is what we use in Western culture, and this is in some ways arbitrary as well. So the reason why, how far is it to go around, what degree measure to go around all the way around a circle? What do we have? All the way around? 360. You do a 360 dunk, you're in the air, spinning 360 degrees, facing the same direction when you dunk or whatever. This comes from Babylonian Empire. They created something called, or they used what's called base 60 to break up increments of time. So where do you think that comes in? Base 60, where do we see that in time? What do you think it's relating to? 60 minutes, 60 seconds in a minute, 60 minutes in an hour, right? That's about as far as it goes. But base 60, our system that we deal with in general is base 10. You count up, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you put a 1 at the tens digit, then you count up, you keep moving over. So every time base 10, every time we get up to 10, we put another digit in the adjacent value place, right? 360 just came from the Babylonians broke up time into 60 different increments for a minute, 60 different increments for an hour. And from that, 360 came from that. It was related in how time was expressed at that time. Okay. So this, actually, Babylonians came up with the base 60 to measure time. That was then spread to Egyptians and Greece. In Greece, a lot of the mathematicians there really incorporated it, now making it 360 degrees. But you can see it's somewhat arbitrary. 360 degrees is because this empire decided to use base 60 for time, then others incorporated it. Just want you to, sometimes it's helpful to see that a real basic piece of knowledge is also arbitrary. Someone decided that this is how we're going to do it. Okay, you guys know this? Radians. If you look at some of the history up here, Akashi and Coates and Thompson were kind of the succession here in speaking about it as diameter parts, relating it to the diameter, angular measure, and then to radians as the measure. Okay. So what I want to just play around with here is, we learned already from the warm-up circumference, 2 pi r, right? If the radius is 1, how far to go all the way around the circle? What measurement in radians? If my radius is 1, if I put 1 right here, right? What is my circumference? 2 times pi times 1. What would that be? 2 pi. With radians, this measurement, we're always starting from this line right here. The measurement is 2 pi to go all the way around. When you have a radius of 1, you can make that deduction pretty quick. Radius of 1, we plug it in. The circumference is 2 pi. So looking at that, how about if I just go a semicircle halfway around? What would that measurement be? 1 pi. So this length right here, this arc length, is pi. You go halfway around a circle, you've gone pi radians. You go all the way around the circle, you've gone 2 pi radians. It's all related to this formula right here. Tomorrow my lesson is talking about the unit circle. That's what this is. 1 unit. 1 unit. The radius is 1 unit long. Right? So I plug in 1 there. I get my circumference as 2 pi. That's how I know with radians. It's 2 pi radians. Halfway around the circle is pi radians. You got to note that it's radians for that. Yeah, those are all paper too. All right, that's just the start. I just wanted to start with that to kind of introduce. Now let's go back to the main board here. I'm introducing some topics like large-scale topics, kind of talking meta, talking more about the theory around it. The 2 things we have to do as far as the 2 methods we're learning today, 2 tasks, are pretty straightforward. So if this kind of started to confuse you, I'm going to talk about this tomorrow in my lesson much more. Let's go back and shift over here. So the way that we find, oh my God, it's written. The way that we find our radian measure is by taking the arc length, which we denote as s, dividing it by the radius. It's just the arc length divided by the radius. So let's see if it's as easy as it seems. What is my arc length right here? 19 seconds. So I know that my theta, if you didn't know this, I want you to write, this symbol is called theta. This is called theta. Okay. theta can be radians or degrees. It's just talking about the angle theta. It's going to be equal to S over R. And let's go ahead and input what is my S, what is my R. Go ahead and divide it out. Find your radian measure for that. Okay. Yes? That's fine. All right, if you're confused, hey, no worries. Let's look a little closer. If you're confused, what am I going to put in for my S value? My arc length S value is 19 inches. What is my radius for this circle? 7 inches. 7 inches. So we divide those numbers. I always want you to get all the way to the 10,000th place. 10,000th place is 4 decimal places. Okay, that's going to allow us to be as accurate as we can. So here we get 2 gets us to 14. Then we have 5 left over, so we get 7, that gets us to 49. We have 1, that's 1. And then 4. And then 2. Is that right?
Did you do that? Okay.
It's just remembering the remainder and dividing it by the same answer.
Yeah, that's a flex.
Just flexing a little bit. Math flex. That's right. All right, so what I have to put in here, if it's in radians, I need to note it radians. Go ahead and write rad after that. Put RAD after that, and I want you to make a star. Don't forget, you have to label if it's radians. When you're doing these type of problems, relating the arc length and the radius, you're always going to find your radian measurement. That's kind of the definition of it. Let's go ahead and do example number 2. I want to see you do that on your own. Find theta. It's just the ratio of our arc length divided by our radius. So what is that going to give us? Just for example 2, go and work that on your own. Ask your neighbor if you need some help to start. So if you're thinking about it, you might just remember, go back to this step right here. What is S? It's my arc length. It's my radius. Remember, the arc length is just, if you're walking along the arc of the circle on the outside, how far is it? So here, what's my arc length?
12.5.
12. What's my radius? 2. Both these are in inches. But you see that those units are going to cancel, which allows us to have just a number, which is our radian measure. So this is actually a weird one. The numbers aren't to scale or perfect for this, but we get 6.25. Okay. So far, so good. It's basically just setting up a ratio, right? Okay. I try to intro what this is even talking about a little to start, but the nitty-gritty of this, again, the lesson's pretty straightforward. So we talked about this a little bit. When we have a half circle, we have a half circle, right? How can we find the theta for that? This takes a couple steps. What do we have to know in order to go and find our circumference? Circumference is what again? 2 pi r. So let's find how far it is to go all the way around. You know what? Let's think about this large scale and just see if we can figure this out deductively. If I want to know my theta is in radians, right? What did we learn before? What did we learn before? Using the idea of the unit circle. So how far would this be? What measurement in degrees would this be if this was a unit circle, if this was a radius of 1? What do we have? 1 what?
1. Right.
1. I just didn't hear you.
180.
180. 180 would be in degrees. How about, so that's correct. If we did this, 180 would go halfway around, right? What did we figure out as far as radians go? 1 pi. So here my theta is equal to pi radians. This was actually a question that was just drawing off the information I touched on first. I want to see if you guys caught that. And I'm not sure if you caught it, so I'll keep going. I'll keep trying to iterate that. All right, let's look at the second bit of this. When we converting between degrees or radians, or converting between radians and degrees, it doesn't matter the order. We're going to use the same approach. We're going to set up a proportion, which is 2 ratios, and one of my ratios is pi over 180. Why is one of my ratios pi over 180? I want you to talk to your neighbor real quick. Why would one of my ratios, here's my proportion, I'm relating two things that are equivalent. Why is one of my ratio pi over 180? So ask your neighbor. Question 2. Oh, the crumbs are the best part. All right, let's bring it back. Who can, for a starburst, who can tell me why it's pi and 180? Yes. You have the dread face going. Just saying. Okay. What's up?
Well, like the 180 is because the half of the circle is 180.
Good. And how does that relate to pi, though? So the 180, I like what you're saying. That's the first step. And how does that relate to pi? Sometimes? Okay. That's okay. You got half of it, so you get half the starburst. Just kidding. You get a whole starburst. Nice catch. Rigoberto, what do you think?
I was going to say because the circumference of the circle is 2 pi, so half of it is just 1 pi.
Just 1 pi? Good. Good. Both of you. Good. So these two are related in a ratio because they are equivalent. Pi is a semicircle. When we're talking radians, remember going all the way around with a radian is 2 pi, so going halfway around is pi. We go halfway. Going all the way around with degrees is 360. Going halfway around is 180. So we relate these two things. These are equivalent as far as radians and degrees go. So here's what I need to do. I need to convert this degrees into radians. So what should I put down here? Remember, it's going to be 180 is the degrees, so everything on the bottom is degrees. So how should I fill this in? I'm going to put what I don't know as radians. I do know degrees. So watch what I'm going to do. 78 degrees. That's where my degrees went. I'm converting it to radians, so I don't know that. So here is theta. Radians, degrees. Radians, degrees, right? They just have to be in the same part of the proportion. So what's our favorite thing to do when we have a proportion?
Cancel.
We like to cancel too. We're going to cancel a little bit. What else? Cross multiply. Cross multiply right here. That's you guys' favorite? So we end up with 78 pi times pi is equal to 180 times theta. This is the only thing that's missing. These are numbers. 180, pi, 78. Those are numbers. The only thing missing is theta. So if I'm just looking for theta, I'm just going to deal with this as if this was 180x. It's just what I don't know. See what I mean? It's just the unknown. When the angle is unknown, we call it theta. All right. Last step. I want to get theta by itself. It's 180 times theta. What should I do? Instead of multiply? Right? We'll come back to you. We're going to divide. Good, Amanda. You got it.
Sorry, I'm so kind of.
What's wrong with you guys? First day of the semester? Already this tired? It's Monday.
Yeah.
Your voice is back. That's good.
Yeah.
All right, 78 times pi divided by 180. 1.3614 radians. Let's see, did I do it to the fourth place? First, second, third, fourth decimal place. I made sure to show that it's radians. And that's the end of it then. We're always showing the answers to the the 10,000th place. That's it. All right, last problem. I'll set you loose on the classwork after this. All right, so for example 5, we're looking to convert 2 pi over 3. That's our radian. We're trying to convert it to a degree theta. We don't know it. So let's set up our proportion. Pi over 180. We know the radian this time, so I'm going to put 2 pi over 3 on the top, theta on the bottom. Radian on top, degree on the bottom. So in this case, our answer for theta is going to be in degrees. It's fine. You'll know by what they give you to start with. So always check the question again. We're going from 2 pi over 3 radians going to degrees. We're going to our favorite thing to do is, with math,
Cross multiply.
Riding my road bike, think of many other things other than cross multiply. I'm with you. Within math, this is pretty good. 180. Starburst point, if you remember, there was a trick that we made this way easier to start. What can we do with pi? You remember this from last year, or my class? What can we do to make this problem easier? Do it? No. We're going to keep it. We're going to actually use the pi symbol so we get all the digits we can get. But what can we do here to make this problem a little bit easier? I can eat it. I mean, can't fish anything out of you right now. No, not quite. No. It's okay. I don't think I phrased that answer.
Actual pie?
That would be a good riddle.
Or no?
No, but I do like apple pie a la mode.
It's worth a try.
Hey, it's worth a try. What you can do right here, you can cancel out the pies. You can cancel out the pies because look at this. This is 2 pi times 180. 2 pi is a whole number. It's not on the bottom of the fraction. This isn't 1 over 2 pi. It's 2 pi at the top. If I divide both sides by pi, essentially I'd be dividing 2 pi by pi. Cancel the pies. Okay. If you don't want to do that, if you're like, I don't trust that, Mr. P might be wrong, then that's fine.
It's not like he's a math teacher or anything.
I'm right, but I'm just saying, if you don't trust me, it's okay. You can still do it the long way and multiply all this together. It'd be fine. But we can always cancel the pies once we have the proportion set up. Okay. Maybe make a note on that. Little hint. Shortcut. Cancel the pies once the proportion set up. So set it up, then you can cancel the pies. And I'll show you. If we divided this whole thing by pi, right? It's pi over 1. Whenever you divide, you end up multiplying the fraction. So we get pi over 3 times 180. We'd end up multiplying it by 1 over pi. Look what happens. See ya. It's like 2 conceptual steps to see how that actually happens. Don't worry. You can work it out the long way. All you would be doing is 2 pi times 180 divided by 3. That gets you a value. Pi times theta, so we divide by pi at the end and just work it out that way. So I am going to go ahead and cancel them. Theta is equal to 2 times 180. 2 times 180, you go half of the way, 180, 360. 360, that's the top values here. 360 divided by 3, 120. Let's look to see. We were going to degrees. Degrees, done. That's it. 2 things we learned. How to find the radian measure using the arc length radius. How to convert between degrees and radians using that proportion. That's it for today. Yeah. Thumbs up, sideways, or down. I saw a lot of tired blinks there. It's just Monday, right? Just tired. Yeah. Sideways is okay. No down thumbs. We're good. All right, guys. Go ahead and start. Today is page 13 in your new workbook, numbers 1 through 10. Make sure your name's on the front of that workbook. Yeah. And I'll put this lesson up online very quick. Let's see. All right. Don't forget to subscribe.